Good day, class. This is a little bit of a homework helper for section 4.3. We are going to be doing some proofs that involve us using side, 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 and side, angle, side. So let's get going. First, let's move this little recorder box down. All right, just a reminder that when we're doing formal proofs, we need to have our map. Our map consists of a statement and reason, and then we are able to use that in trying to do our logical flow to the final proof. Okay, 21 says for us to prove that triangle NPQ is congruent to triangle RST. And if we look at the drawings here, we can see we have the two triangles. And our given statement says that NP is congruent to QN, which is congruent to RS, which is congruent to TR. And I notice automatically that I have a side and a side matchup. And my other given says that PQ is congruent to ST, that's another side. So looking at this, I see that I have side, side, side. And so I'm actually ready to complete the proof. Let's just highlight that I have a side here, and that we could prove these two sides over here. So side, side, side. We've got all these sides that match up. So we've got side, side, side. So step 2, triangle NPQ is congruent to triangle RST. And my reason is because I have all those side, 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 side. Just a 2-step proof. 22. We are given that line AB is congruent to line CD. So I'm going to give a little hash mark. And that AB is also parallel to DC. So there must be a reason they're giving me that. I probably need that for this proof. And I need to prove that triangle ABC is congruent to triangle CDA. I also recognize right now that AC and CA are the same line, are they not? And they're shared by those two triangles. So my first step is this, that I recognize that. But let's talk about this AB being perpendicular to DC. I'm going to draw AB and DC over here just so I can see it. And it looks like that line AC is a transversal. And if these two lines are parallel, then I know that these two interior alternating angles would be congruent. So I'm going to say that for my second step. That angle 1 is congruent to angle 2. And my reason is because of alternating interior angles. So I actually have an angle for this now, don't I? I have an angle. And I have that given side that was right here. So I have a side and an angle. It looks like I need another side, and we already talked about that side, that it would be AC congruent to CA because of reflexive. And I've got side, angle, side now. Here's my other side. So I've got side, angle, side, and I've proven that triangle A, B, C is congruent to triangle C, D, A. 23. 23, I'm given that ray, PQ, so this right here, bisects angle SPT. And I remember from definition of a bisector that it cuts the angle exactly into two equal angles, or two congruent angles. So I've got these congruent angles here, because my line bisected them. And my other information tells me that SP is congruent to ST. And the other thing I recognize is that that line PQ is the same as QP by reflexive. So I've actually already found all the information that I need. Right here in the given, I have a side. And my second step, I'm going to say that angle SPQ is congruent to TPQ, and that's because of definition of a bisector. My third step, so there's my angle, isn't there? So I'm going to mark that as an angle. So I've got a side and an angle. My third step I wanted to show was that PQ was congruent to QP, and that was reflexive. That's my other side, so I've got side, angle, side. And according to that, that is proof that these two triangles are congruent. So I can say triangle and PQ congruent to triangle RST. #24. Here I'm given some information that PT is congruent to RT. So here is PT, and it's congruent to RT. So I'll give them each a little 1 hash mark. The other one says that QT is congruent to ST, so they're going to get double hash marks. I'm thinking, how's that going to help me? But let's look and see what triangle we're trying to prove. We're trying to prove PQT. So there's one triangle, and the other one is RST. There's our second triangle. And as I look at that, I begin to see I have a side and a side, and I just need an angle, and lo, look at there, I have a vertical angle, don't I? So I'm going to use vertical angles to help prove this. So my first thing that I can do is I can recognize that here's a side, and here's a side. And then the second thing I'm going to say is angle STR is congruent to angle QTP, and that's because of vertical angles. And there is an angle. So I'm going to let you finish out this next step. I do have side, angle, side. So what do I need to do to finish it? I'll let you finish that one out. 25. Here I know that AC is congruent to BC. So I'm going to give some congruent marks there, so I know that. And M is the midpoint of AB. What can I do with that? Well, I know that if it's a midpoint, by definition of midpoint, that M cuts the line AB into two equal parts, AM and BM. So I can say that these two are congruent because of definition midpoint. And then my third one, I can say it's congruent because of reflexive. So let's go ahead and write those steps down. The first was given. There's my first side. The second one, I said that AM is congruent to BM, and that was a definition of midpoint. And my third, and that was my other side, right? And then I had a third side that I could say I got it because CM is congruent to MC. That's reflexive. And finally, I do have side, side, side. So what should my fourth step be? What should that be? Make sure you finish that one out. I'll be looking for that on your homework. And finally, 26. We're almost done. This one's a little more complicated. So let's go over the information that we have. This is actually a given right up here. So my given information says that BC is congruent to AE. So this line is congruent to that line. Hey, that's already a first side. So I'm going to mark that as a side. And then it tells me that BD is congruent, so this segment right here is congruent to AD. BD congruent to AD. So I'll just do, they're congruent, all right, make those double hashes. And then it tells me that D is congruent to DC. That would work if I were using and trying to find triangle BDC, but I'm actually not. I'm trying to find triangle, let's look at the triangles that I'm trying to find. ABC, so A, B, oops, back that up. A, B, C, so this triangle here. And the other one that I was trying to find was triangle B to A to E, so that triangle. And what I do recognize is they share this common line, don't they? So once again, I have a reflexive property going on. In fact, I'm going to put that down right now. I'm going to say that BA congruent to AB, and that is reflexive, right? And of course my given stuff here, I better get that down. My third, what would my third be? I need to somehow prove that AC is congruent to BE, but I don't have any information on that. But what I do know because of the rule of segment addition, that BD plus DE, the measure of them, is equal to BE. And I know that AD plus DC is equal to AC. And that's just called segment addition. And I need to do that because I'm going to do some substitution so I can do some transitive work to prove two things are equal. That's I. Segment addition. Okay, so my fourth thing that I'm going to do is going to be a substitution thing. I want to make BE and AC look the same on the left side. And I know that BD is equal to AD from my given up here. So instead of BD, I'm going to write AD in its place. I'm going to substitute AD. And I also know that DE from my definition, or my given up here, is the same as DC. So I have rewritten this equation right here in terms of this with substitution. So I'm going to put substitution. Now, if AD plus DC is equal to AC and AD plus DC is equal to BE, by transitive I can say AC is equal to BC. And now AC, BC are my third lines that I was trying to show. So I've got another side here. Don't forget to mark this was a side. And here's my third side. So I've got side, 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 don't I? And therefore, I can finish it out with a side, side, side. And I can write my proof right here as triangle ABC congruent to triangle BAE. All right, it looks like we've got that. Any questions about the transitive section? You just remember BEA is equal to AD plus DC. AD plus DC is equal to AC, therefore BE must equal AC. And did I put BC again? This needs to be E. I keep doing that. BE. Now let's get it in black. B, B, E. This is D, C. My board gets a little burped at the bottom. So AC is congruent or equal to BE. And we could actually add a step in there and talk about congruence and say definition of congruence. But we're just going to go with this, and we'll be good. All right? All right. Good luck on the rest of your assignment.